Students, today's lesson is a continuation of classification of matter. On yesterday, we laid the foundation that matter can be divided into two main categories. And the first main categories is either a pure substance or a mixture. And then where we left off was the further subcategories of pure substance, where the pure substance can be either an element or a compound, okay? And so to review what we talked about yesterday, remember that an element is a sample of matter in which all the atoms are exactly alike. As you see here, this Coach Jones blob represents a sample of hydrogen gas. This hydrogen gas is classified as an element. The reason being is all the atoms of this substance are exactly alike. The only type of atom in this sample is hydrogen, or from the element hydrogen. So students, as you see in this particular blob right here, how many elements are present here? One element. Very good. As opposed to this type of matter here, where this particular classification of matter is not an element. There are two or more elements, but they were chemically combined with a set ratio of 2 hydrogen atoms for every 1 oxygen atom. So when 2 or more elements chemically combine with a set ratio, it forms a compound. And the general misconception with a compound is that some students think that a compound is mixed. Is a compound mixed?
No.
No, it's pure. So when hydrogen bonds or chemically combines with oxygen, it forms pure water. All right, and then quickly to go through what we talked about yesterday, this first sample here is a sample of hydrogen gas mixed with oxygen gas. This is a mixture. This sample here is a mixture of water with hydrogen peroxide. This is also a mixture. This sample here is pure. It's a pure substance, but it's an element. Once again, it's the element hydrogen. Over here, some students would think that this sample is mixed. Is this mixed?
No.
This sample is pure. It's purely what? Water. It's purely water. Some would argue, well, wait a minute. I see 3 substances in this sample. I see hydrogen, I see oxygen, and I see water. The answer is no. When elements combine chemically, they cease being their former selves and they become a completely different substance. Water doesn't look like oxygen. It doesn't look like hydrogen. It doesn't look like a combination or a mixture of hydrogen and oxygen. They're completely different. Different melting points, different boiling points, different density. They're just completely different substances. Is that clear?
Yes.
All right, now let's start what we're going to talk about today. All right, did we get this far yesterday?
No.
All right, so today we're going to get into classifying matter given various examples, okay? For example, we have a sample shown here. All right, first of all, students, question 1. How many atoms are present in this sample? Remember, each capital letter in my notation represents an atom. Okay, Frankie.
13.
13, very good. So, students, 3 atoms here, 3 atoms here, 3 atoms here. That's 9 atoms that make up the water sample, and then there's 4 more atoms that make up the oxygen gas. So that's 13 atoms that are present in this sample. Does that make sense? Any questions on that?
No.
All right. Now keep in mind, an atom is not a type of matter. It's not a classification of matter. An atom is a unit of matter. Okay. So an atom is a unit of matter, not a type of matter or classification of matter. Now let's move on. How many elements are present here? Keith.
2 elements.
Name them.
Oxygen.
Oxygen. Oxygen and oxygen. Corey.
Oxygen and water.
Water's not an element.
An H2O.
Jimmy.
There's one element, oxygen.
There's only one element present here, and that's oxygen. Okay? Now, I always give my students a hint when they're classifying a matter. It gets confusing. I see how Keith said that there's two elements here. He's probably referring to maybe this element and this element. Is that what you're thinking, Keith?
Yes.
All right, that's a common mistake by most 8th graders. But once again, an element is not a unit of matter. It's a type of matter. It's a classification of matter. Okay? Yes, Frankie.
So when one element combines with the same type of element chemically, it does not become a completely different substance?
Well, it behaves differently, but it still belongs to that family, that element called, in this case, oxygen.
So when oxygen bonds with multiple other oxygen atoms, it's still oxygen?
That's correct. That it still falls in the category of oxygen. A single oxygen atom is unstable oxygen. Two oxygen atoms combined chemically forms a stable oxygen molecule. Does anybody know what 3 oxygen atoms combined forms?
Oxygen?
It's still the element oxygen, but in that form it's ozone, which is still oxygen. Okay? Jimmy, you say ozone? All right, very good. All right, students, how many compounds are here? Frankie?
There are 2.
Okay, name them.
H2O and O2.
O2 is not a compound. O2 is an element. Okay, Austin,
This one,
name it.
H2O.
Very good. So, as I was going to say earlier, I have a hint that I always tell my students. If in doubt, name them. That's the Coach Jones hint. If in doubt, name them. If I ask you how many elements are present and you're not quite sure, name them. If you start naming the elements here, you say, okay, there's oxygen and then there's oxygen. Have you named 2 elements?
No.
You've only named 1 element, okay? For compounds, okay, there's water, then there's water, then there's water. You've only named 1 compound. So now you know that there's actually 1 compound, 1 element. Lastly, how many mixtures are in this sample? Austin?
1 mixture.
1 mixture. Very good. For a given sample, y'all, for a given sample, for a given container, at most you can only have 1 mixture. Does that make sense?
Yes.
You can't have 2 mixtures because if you add different things, it's still 1 mixture. Make sense? A sample is either pure or it's mixed. A sample is either pure or it's mixed. Okay, last thing I'm going to say for this is for those of you who like math, anybody like math? Okay, a few people. For those of you who like math, you can get a mathematical relationship between E, C, and M. And here's how it goes. If E plus C greater than 1, then M equals 1. And that's purely mathematical, but if you think about it, it makes sense. If you have substances that are greater than 1, if you have more than 1 element plus more than 1 compound, then it's a mixture. Does that make sense?
Well, we already have only one element, 1 compound, but then we still only have
Right. So to say it clearly, if the sample has more than 1 substance, it's a mixture. That's what this is
So
saying.
basically, if E plus C is less than 1, then M equals 0.
If E plus C equals 1,
Is less than or
if E plus C if it equals 1, then M equals 0. Does that make sense?
Yes.
All right. So if in the sample there's only one element, or if in the sample there's only one compound, then the sample is not mixed. So it's either mixed or it's not. Got it? All right, very good. That'll conclude our mini lesson on classifying samples of matter.